Hey grade 12s, today we're going to do probabilities and counting methods. So we're going to be doing all that fun permutations and combination stuff, but with probability. So example, Natasha and Dakota make the track and field team. In an 8-person race where every racer has an equal chance of winning, what's the probability that both Natasha and Dakota end up in the top 3? So what we have to do here is we have to consider that we have to choose these people, and then what we have to do is then we have to figure out how many ways they can place. So what I can tell you here is that if we have the 3 people in the top 3, and we're not worrying about order yet, okay? We're just picking the people first. If we're not worrying about order first, then I know that in the 3 racers that in the top 3, I know Tasha's going to be one, I know Dakota's going to be another one, and there's 6 people that can go here. So in other words, there's 6 ways I can choose 3 people to fit in the top 3. But now, with those, basically, because there's one way to choose Natasha, there's one way to choose Dakota, so there are 6 ways of choosing the racers. Okay? But for every one of those possibilities, there's 3 factorial ways of arranging them. So there's 6 times 3 factorial ways for Natasha and Dakota to end up in the top 3. So 3 factorial is 6. So it's going to be 36 ways that this can happen. Now the probability, of course, is the number of favorable outcomes over the total number of outcomes. So the probability of Natasha and Dakota in the top 3 is going to be 36 over the total number of outcomes. Now the total number of outcomes would be, well, it would be 8 pick 3. 8 pick 3. Now of course 8 pick 3 is just going to be 8 times 7 times 6, which is, what is that? That's whatever 56 times 6 is, which would be 236, I think. No, sorry, 336. It's 336. So it's 36 over 336. Now if we reduce that, those can both be divided by, well, 3 for sure. Actually, if we want to reduce this, it's just going to be 3 over 28. Divide them both by 12. And, oopsies, I don't know how to write apparently. Okay, so it's 3 out of 28. That's the probability that Natasha and Dakota finish in the top 3. If we want to write that as a percent, that would be 10.7% chance that they both finish in the top 3. Okay? Next example. A fair coin is flipped 3 times. What are the odds in favor of getting at least 1 head? Okay, so a fair coin is flipped 3 times. What's the best way of doing this question? I would say, now I know we're talking about counting. One of the ways we learned how to count was with a tree diagram. So I've got, here is a nice tree diagram. There's heads, there's tails. There's heads, there's tails. There's heads, there's tails. And now, let's do heads and tails again. Heads, tails. Heads, tails. And by saying a fair coin, we assume that the probability of getting heads or tails on any given throw are equal. In other words, they're 0.5. So what we have here is we have a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So those outcomes are triple H, heads, 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 HHT, HTH, HTT, THH, THT, TTH, and triple T. So those are the outcomes, or the sample space, of flipping 3 coins. Now the question asked, what are the odds in favor of getting at least 1 head? So we need to find the number of outcomes where we have at least 1 head. Well, this would be one such outcome, another. This right here is the only one that does not. So how many outcomes do have at least one head? 1, 2, 3, 4, 5, 6, 7. So the odds in favor would be 7 to how many outcomes do not have at least one head? 1. So the odds in favor of getting at least one head are 7 to 1. Okay? Next example. A 5-card hand is dealt from a deck of well-shuffled playing cards. What's the probability of getting a flush? A flush is all cards of the same suit. So let's pretend we're going to get all hearts. How can you do that? You can do that in 13 choose 5 ways. So what is 13 choose 5? 1287. Now, you can get a flush that's hearts, but you can also get a flush that's clubs. That too would be 13 choose 5, which would also be 1287. You can also have all diamonds. If you have all diamonds, it's still 13 choose 5, which is still 1287. And last but not least, we could have all spades, which is 13 choose 5 again, which is 1287 again. So what's that going to be? That's going to be 51. 13 times 4 is 52, so it's 48. So 5,148 ways of getting a flush. Now that's the total number of favorable outcomes. Total number of favorable outcomes. Now, how many outcomes are there altogether? Well, the total number of outcomes altogether would be whatever 52 choose 5 is. So, what is 52 choose 5? Well, that's going to be 2,598,960. And if we reduce that into simplest terms, I don't know. I wouldn't even bother, to be honest. I would just write it as a decimal. So let's do that. 5148 divided by 2598,960 equals, it's very small. It's very small. It's going to be 0.00198. And that is as a decimal. So if we want to move it over, so we write it as a percent, it would be still small. It would be 0.20%. If we round 20%, that is like 1/5 of 1% chance that if you deal yourself 5 cards from a well-shuffled deck of 52, you're going to get a flush. Okay? And we have one more example to leave you with here. That is, Dakota and Steven decide to have a Seinfeld party. Sounds like a great party to me. Almost as good as a math party. They have Season 2, which is 12 episodes, and Season 4, which is 24 episodes. They want to watch 4 episodes. What's the probability that they will watch 2 episodes from Season 2 and 2 episodes from Season 4? Okay? So, first off, the number of favorable outcomes will be 2 episodes from Season 2, 2 from Season 4. So that would be 12 choose 2 times 24 choose 2. That's the number of favorable outcomes. Okay? So what's 12 choose 2? 12 choose 2 would be 66, I do believe. Yep. 24 choose 2. Oopsies. 24 choose 2. 12 times 23, which would be 230. Plus 46, 276, but I'll check it. No, it is 276 indeed. So we multiply 66 by 276, we get 18,216. So there's 18,216 ways that they can choose 2 episodes from Season 2 and 2 episodes from Season 4. Now, that's the number of favorable outcomes. Now the probability is going to be 18,216 divided by the total number of outcomes. Now the total number of outcomes is going to be equal to the total number of episodes. There's a total of 36 episodes, and they're choosing 4 of them. So it's 36 choose 4, whatever that is. So what is 36 choose 4? 36 choose 4 is going to be 58,905. So if we divide 18,216 by 58,905, we get 0.30924, which would give us a 30.92% chance that Dakota and Steven will watch 2 episodes from Season 2 and 2 episodes from Season 4. Now let's look at this last example that says they will watch 4 episodes from Season 4. Now, of course, in this whole example, we are assuming that it is an equal probability that Steven and Dakota will pick any episode from either Season 2 or Season 4, but they'll watch 4 episodes from Season 4. Now, in Season 4, we said that there was 24 episodes, so it's going to be 12 choose 0, because they're not choosing any episodes from Season 2, times 24 choose 4. That's going to be 1 times 24 choose 4 is 10,626. So that's going to be 10,626. Now we know the total number of possibilities already is 58,905. So it's going to be 10,626 over 58,905. And now we're going to get a probability of 0.18039, which is going to be 18.04%. So it's a lot less, but that is the probability that they're going to watch 4 episodes from Season 4. It's 18.04%. Alright? And because we're using combinations, we're assuming that order doesn't matter. It doesn't matter the order in which they watch the episodes. Okay, so your homework is on pages 3. Is that 3? 321 to 323. It's numbers 1 to 17. You will have today as well as Friday to work on these. Monday you'll do a quiz and then get a period to work on your design and measurement.